Well, hello and welcome to this session of the application week where we're going to focus upon spring grass weed control and specifically look at AXIAL Pro and wild oats, albeit what we say will also be relevant to ryegrass as well. Just to introduce myself, I'm Duncan Woodward. I work in the Southwest for Syngenta as an area manager. So if we launch right in, what we're trying to achieve with AXIAL Pro, or indeed any other product, is as close to 100% control as we can. And anyone who's been to a Syngenta application meeting for the past 20 years or so would recognize this chart, or this way of describing how to achieve that 100% control. Effectively, about half of the control that you're trying to achieve is in the product. The rest of that 100% control happens outside the can. So that is very much in the farmer and the agronomist's hands as to how well that product delivers the control. So if we look at what happens outside the can, we can look at, say, timing and weather, say 20%, mechanical, so how the sprayer is set up, 20%, and then the fine tuning around nozzles and water volumes. You might argue the toss about whether those numbers are absolutely correct, but hopefully it gives an indication that it's important how you handle the product as to what kind of result you get. We're going to focus on fine tuning and timing and weather in the subsequent slides, but before we move on, just to say about the mechanical side of the operation. I'm thinking there about boom height, and any application discussion should mention boom height, because boom height has a big impact upon performance. If the boom height doubles, then drift goes up by a factor of 10. And drift is not only important from an environmental point of view, it's also a function of inaccurate application. So boom height remains a vital component. And also on the mechanical side, you can also think about forward speeds, which for grass weed control should be 12 kilometers per hour or less, and also think about tire pressures as well. And here I should draw your attention to some video content that we have, which we discuss tire pressures and the impact upon boom stability. That's worth watching. I should also mention at this point, we're talking here about efficacy. Efficacy is one part of the proposition of application. You're also thinking about how efficient the application can be, and also about environmental considerations. So you're very much balancing those three components. So moving on to the weather, which we always talk about in agriculture. It's the one main factor that influences our results, which we have no control over. Usually when we talk about weather in terms of application, we're thinking about spray windows. How many spray windows are there in the season? And they're very often few and far between. But in this particular situation, we're thinking about the effect of the weather upon the growth and therefore the susceptibility of the target weed. So here we've got two weather charts. The top weather chart is about temperature, and the blue line here charts temperature in 2021, and the red line charts temperature in 2020. And we're looking here between the 1st of March and the end of June. The lower chart looks at daily rainfall, and again, the red line is 2020, the blue line is 2021. What we're seeing here, and it's in fairly recent memory, so you'll remember that in 2021 we had some very cold conditions in April relative to 2020, and in both seasons, in fact 2020 and 2021, we had a real dry spell from sort of the third week of March up and towards the end of April. Now, you'll probably think about these kinds of conditions in terms of their impact upon the crop and the decisions that you're making about the crop, the disease pressure that you've got, and the growth regulation decisions you have to make. But bearing in mind what affects the crop growth also affects the weed growth, and therefore these kinds of conditions affect the grassweed growth and therefore the grassweed susceptibility. Just to highlight that, we're going to go back to some data that was generated in the laboratory at Jellet's Hill with laboratory grown wild oats. And what we're trying to do is manipulate the conditions that the wild oats are grown in and seeing how those different conditions affect performance of products. As I say, it's grown inside the lab, so don't worry about the dates. It's in December, but they are lab grown, so it's not like it's outside. So what we have here is application that was made on the 27th of November. And here we are looking over a period of time at assessments, looking at the level of control that's achieved. So the application was made at around growth stage 37 of the wild oat. And what we have are wild oats grown in either standard conditions, which basically means that they are given 100 mils of water a day, or they are held in dry conditions, which means they are given 30 mils of water per day, or they're dry followed by wet. The 30 mils of water effectively keeps them going, but only just. So it's in effect simulating wild oats in a dry stroke drought situation. What we can see here, the gray line is the progression of control of AXIAL Pro over time as we assess over time towards the third week of December. And you can see that compared with the other two growing regimes, the control is more rapid and you get towards the level of control that you desire more quickly. The other two regimes do get towards the level of control eventually, but clearly there is an impact on performance due to the dry conditions or the dry followed by wet. If we go out into the field and have a look at timing in terms of control, so before we're looking at weather, this is more about timing in terms of, say, growth stage. What we have here is a NIAB trial carried out this year at Hardwick, and this is in winter wheat. And I would just draw your attention to the y-axis. This is wild oat panicles per meter squared. So basically, the bigger the bar, the worse the level of control we're seeing. So the bigger the bar, the poorer it is. And so we have two different timings going on here. Growth stage 32 and growth stage 39. So we've got a lower dose of AXIAL Pro here at 0.4 with Adigor, which you have to add if you're going to drop the dose down that far, or 0.6 of AXIAL Pro, or 0.6 at growth stage 32, and then 0.6 of AXIAL Pro at growth stage 39. And what you can see is, first of all, it's better to apply the 0.6 litres per hectare of AXIAL Pro. You get the better result compared with the 0.4 at the early timing. But the earlier timing is by far and away the better moment to hit the wild oats compared with the growth stage 39 application. You've actually lost 50% control there simply by going for a later application timing. Earlier on in the crop and the weed cycle, you've got less influence of the canopy, which is something we'll come back to. The canopy does intercept the crop spray and means that individual plants, which are smaller, get earlier on in the lifespan of the crop and the weed, the earlier application, the individual weeds get a higher dose of product compared with the later applications. So if we go back into the lab again, looking at this trial that we carried out at Jellet's Hill in 2019, if you recall, these are laboratory grown wild oats, sprayed on the 27th of November at growth stage 37. Here we're looking at the differences that products can make in terms of control. So we're looking at these different bars are studying the different timings of assessments. So what we're seeing here is a progression of control over time. And what you can see is that you've got to choose the right product. These wild oats were grown in dry conditions, so it's automatically a more challenging target. And we can see that AXIAL Pro does get to the 100% control in the end. Slower, if you recall, than when we had wild oats that were grown in good conditions, but it does get there in the end. Compare that with Foxtrot, phenoxyprop, it is clearly not as good. So we've actually, you have to choose the right product to get the right result. It's an important part of the decision process. And going out into the field to look at this, this is a trial from 2020 carried out at Hollington in Warwickshire. So we have down here, we've got Planet spring barley drilled on the 1st of April, and we've got product that was applied late. So 15th of June, the crop is at 59, which I should emphasize is beyond the label recommendation, but it's an interesting challenge. The weed is actually at growth stage 32. So if you can imagine the scenario here, we have the weed which is within the canopy rather than necessarily above the canopy, and so it's quite a difficult target to access. So here we have AXIAL Pro at 0.4, 0.6 and 0.8 litres per hectare, and Foxtrot at 0.8, 1 and 1.2 litres per hectare. And again, in this scenario, the bigger the bar, the better, because we're looking at percent control, but we have assessments over time. So the first assessment was carried out on the 30th of June, then another one 6th of July, and then the final assessments carried out at the end of July, 29th of July. And so what we're seeing here is actually with a lower dose of AXIAL Pro plus Adigor, which we would not recommend in this situation, we're getting quite useful control, but that does then tail off. So what we're looking at here is actually regrowth. So we had some initial useful control, but then we've got tillers coming back and regrowth. We also see that to a lesser extent with a 0.6 litres per hectare, and to a lesser extent again, you've almost got exactly the control that you need by going at the higher dose of 0.8. Bearing in mind this is a challenging situation with crop competition and crop interception of the spray. The different product here, Foxtrot, is simply not as good. Yes, you have the same pattern in terms of you get regrowth manifesting itself at the later assessments, but the initial control itself does not match the level of control that you get from AXIAL Pro. And there are some images on the right-hand side here, which have been enhanced to sort of pull out the green, which is the wild oats in the crop, and you can see again that the AXIAL Pro versus the Foxtrot is very different in terms of the level of control that you're achieving.
Thanks, Duncan, for taking us through that. So I should introduce myself. I'm Georgina Woods. I am Field Technical Manager based just south of Cambridge. And I'm going to take us through some of the recent application work that we've done looking at how to achieve the best grassweed control. So the first thing I should say is that every year Syngenta invests quite a lot of time and money as well into doing these types of trials. And Duncan mentioned before some of the work that we did at Gellets Hill, which is our main research centre in the UK. On the screen now, you can see some images from that work that we did this year, which shows how it's done. So we have a track sprayer, which is set up in the lab. And we look at different targets and analyse the deposition of the spray that we get onto those targets. So in the pictures there, you can see a flat target, which is just a sheet of paper. So that's simulating the soil surface, but also helps us to calibrate the spray that we've got. And then in the picture next door to that, you can see there's some tiny little upright steel rods, which are mimicking small upright targets. And we can look at those either without a crop canopy, or also where we've grown up a crop canopy, we can slot those in and we can look at the deposition that we achieve on weeds. So these are simulating weeds in the bottom of that canopy. So where we have later germinators, which are coming through, we can analyse whether we achieve good contact of our spray onto those late germinators. That's traced using tracers, which are then washed off and analysed in the lab to give us a measure of the amount of active that we've delivered to those different targets. So if we have a look at some of the data that we got this year, first of all, this has been done looking at angled versus straight down nozzles, so vertical nozzles. And what you're seeing here is spray deposition on those small upright targets, and a comparison between having those within a canopy and not in a canopy. So on the left-hand side here, we've got the angled nozzle, and on the right-hand side, we've got the vertical nozzle. First of all, you can see that where we don't have a canopy, so where we have an open structure out in the field, so that would be in a peri-em situation where you've got crops and weeds coming through at the first true leaf stage, or through to where we've got that crop still open but not hitting stem extension yet. So all of the plants from above can be seen because that canopy is really nice and open. We've got much higher deposition figures with the angled nozzle versus the vertical nozzle where we don't have a canopy. Where we do have a canopy, you can see that there is ever so slightly greater deposition within the canopy with the vertical nozzle as it's pointing straight down and getting more contact onto those small upright targets. So the difference there is relatively small versus the benefit of the angled nozzle in an open canopy. What we then do, once we've got some analysis from the lab, is we take that theory out into the field. And from this picture here, you can see at the top here where we have small plot trials, which are done using handheld sprayers, are generally looking at comparing products and timings and applications done in the same way using that handheld sprayer. We then expand that and we have two small sprayers which are set up exactly like a crop sprayer, and we can take our understanding of those different products and timings and also the nozzles that we've achieved from looking at in the lab, and we can take that theory out into the field and check that what we've seen in the lab translates into a field situation as well, which it did. So where we did some efficacy work with AXIAL Pro looking at vertical versus angled nozzles at an early timing, this is back in 2017-18 season, you can see that the angled nozzles gave better efficacy at that early timing as well. So the theory that we've seen in the lab is that we get greater deposition of that product at the early timing with an angled nozzle, and that did translate into, in some cases, a 15% uplift in the efficacy that we saw as well. The other trial that we've done this year, and this goes alongside some of the work that Duncan mentioned with the timing work at NIAB in Hardwick this year, we also looked at different nozzles and water volumes as well. And what we've seen is, although there wasn't a huge difference with the different nozzles at the growth stage 39 timing, and on the chart here again, as with the NIAB trial that Duncan showed, we're looking at wild oat panicles per metre squared, so lower bars are better efficacy. We can see that there is a trend towards the lower water volume delivering better efficacy. That's something that we've seen before with AXIAL Pro, because where we have lower water volumes, we have a higher concentration of active in every droplet that hits the target. And that's particularly important with AXIAL Pro, with it being such a difficult target to hit. If every time we hit it, we have more active in that droplet, we're actually going to deliver more active overall. So then, to summarise everything that we've been through just now, I think number one, in terms of achieving the optimum weed control, is prioritising it. The impacts of poor weed control go across several seasons because we're always thinking about the seed return that's generated. So where with fungicides, typically the impact is on that one crop in that one season in terms of the yield that you deliver. With weed control, the impact is multi-season, so it really does need to be a priority. Timing is almost everything, and that was shown by Duncan with the NIAB trial, where we saw that the later application reduced the level of control that we got by 50%, which is actually a much greater figure than is quoted on our chart that we've been using over the years, but this shows an average. And we know from that work that we've done at Gellets Hill in the lab that weather conditions can have a really big impact on performance. So that's a really important consideration when thinking about the timing of using products such as AXIAL Pro. We know that AXIAL Pro is the best product for the job, and we've seen that particularly in dry conditions, the performance and the speed of activity from AXIAL Pro is much better than with Foxtrot, and that was demonstrated in that lab trial that Duncan talked us through. Finally, we're focusing on the fine-tuning element, which is putting that product in the right place. And we've seen that angled nozzles deposit more of the spray on small upright targets in an open canopy, and that lower water volumes when the crop and the weed are at flag leaf delivers a higher concentration of active to give us better control. So overall, if we're adding all of those different elements together, including things like boom height and tire pressure, which Duncan mentioned, and the fine-tuning elements at the right timing, hopefully we can get towards the 100% control that we're looking to achieve. Thanks very much for watching.